Hello everyone, welcome to Study Creatively, which presents chemistry, important equations and formulas from the chapter Some Basic Concepts of Chemistry. So, in today's video, we are going to be talking about the basic concepts of chemistry. So, let's start. So, we start with the mole concept. What is mole concept? Now, what is mole concept? So, first thing that we need to remember in the mole concept is your molar mass. Molar mass is nothing but your mass of one mole. So mass of one mole will determine your molar mass. So mass of one mole. 1 mole ka mass is nothing but your molar mass. So this is your first concept that you need to remember from the molar concept. Then 1 mole will be equals to mass of 6.023 into 10 to the power 23 particles or atoms or molecules. Particles here means we are talking about both. We are talking about atoms also and molecules also. So these were the two things that you need to remember from your mole concept. There are various other things also, like 1 mole atom is equals to gram atomic mass. Okay, so let's see into the slide what we are talking about. 1 mole atom. 1 mole atoms is equals to gram atomic mass. Gram atomic mass. Then you have 1 gram atom, which is N of A atoms, which is equals to 6.023 into 10 to the power 23 atoms. So that's it. So 1 gram atom is equals to this much, and then 6.023 into 10 to the power 23 atoms to the power 23 atoms. Then 1 mole molecule. 1 mole molecule is equals to gram molecular mass. Gram molecular mass, which is 1 gram molecule. 1 gram molecule. So that's for 1 gram atom, 1 mole molecules. Now talking about 1 gram molecule. We talked about 1 gram atom. Now moving on to talk about what is 1 gram molecule. Now 1 gram molecule is equals to N of A, which means Avogadro's of number of particles. Avogadro's number of particles molecules is equals to 6.023 into 10 to the power 23 molecules is equals to gram molecular mass, which is again 22.4 liter of any gas at STP. Okay, now 22.4 liter of gas at STP is nothing but 6.023 into 10 to the power 23 molecules of gas. Number of moles formula to calculate is nothing but given moles of particles upon Avogadro's number of particles, which is N of A. That's how you calculate number of moles. Then talking about calculation of molecular weight, which is molecular mass is equal to 2 into vapor density. Molecular mass can even be calculated by mass of 22.4 liter of vapor at STP. So 22.4 liter of vapor at STP is also equals to the molecular mass. So there is two ways to calculate the molecular weight. First way to calculate molecular weight is by the formula twice the vapor density. Then second is mass of 22.4 liter of vapor at STP. Then we are going to be looking at how to calculate equivalent weight, which is equation with of an element 80 dot weight of element upon valency of element, then of a compound molecular weight of compound upon total charge on its cation or anion. So cation and anion में जो भी total charge होगा, which will from that you are going to be dividing it. So now moving on to the next part, which is your equation with respect of anion. We talked about a compound. Now talking about anion, let's see that what it is. Now equation with respect to anion. Okay, so anion ki equation that we have is this one. Anion equation with respect to anion of anion is formula weight. Formula of ion upon charge of ion. That is anion. Then you have equation with WT which is equals to WT dot deposited by 1 Faraday, which is 96,500 coulombs. Okay, by 1 Faraday, which is nothing but 96,500 coulombs. So this is the unit that you need to remember with 1 Faraday. Then moving on to the equation with of an acid equation. So anion formula of weight of iron EQ weight WT dot deposited by 1 Faraday 96,500 coulombs is what we discussed. Now moving on to EQ weight of an acid, mole weight upon of the acid upon basicity. Now remember what is in the base, like the only difference is into the base. Like if you see here, you have acidity, here you have basicity. In the two, when it is base you have acidity, when you have acid you have basicity, so just the reverse of each other. So that's the trick to remember the formula. If you have to find the equation of WT of acid, then it is going to be mole dot to WT of the acid upon basicity, base upon acidity is for the equation WT of a base. Then equation of salt is molecule weight of the salt upon total positive valency of the metal items. Okay, so now moving on to the equation WT of oxidizing or reducing agent, which is MOL, molecule weight of the substance upon number of electrons gained or lost by one molecule. Talking about the calculation of atomic weight into specific heat, which is equal to 6.4 approx, which is also known as Dulong and Petit's law for solids. So remember how you have to calculate the atomic weight, which is atomic weight into specific heat, which is approximately 6.4. Talking about something like exact atomic weight, which is equation of weight into valency. So if I'm going to be talking about things like exact atomic weight, then it is going to be nothing but equation into WT into valency. Okay, I hope you know what is valency. Now if you want explanation also of this chapter, so write down in the comment section. Here I'm just discussing the formulas and the equations that are related to the chapters and which are very very important. Okay, so this was all for today. In the next part I'm going to be talking about next chapter and the points that you need to remember in chemistry and the physics. Okay, so stay tuned. And don't forget to like, share and subscribe the channel. That's the key for me to get motivated and do more for you.